In the last method we used to solve quadratic equations, we used the method of factoring and the zero product property to find our answers. And that works when you're able to factor quadratic equations. Sometimes you'll run into problems that will not factor. And when that happens, we can use a method that's called completing the square. And it's very nice because completing the square works regardless of whether your quadratic equation factors or whether it is unfactorable. And there are a few steps to remember as we're solving these. And it'll be good to have these written down at least while we practice our first few problems to help us remember what to do. So let's look at example 1 and consult the steps. Step number 1 says to write the equation so that it's in the form x squared plus bx equals c. Now if I look at example 1, I already have that in this form. We have our x squared term, our bx, and then our constant is already on the right side of the equal sign. So we're ready to skip to step number 2, which is where the completing the square part comes from. A says to take half of the b coefficient. So our b coefficient is -6. Half of -6 is -3. B says square it. So we're going to take -3 and square it. That will give us +9. And now we have to add the square to both sides of the equation. So I'm going to rewrite our equation, x squared minus 6x, and I have to add this 9 to the left side. I'll write +9. I also have to add it to the right side to balance our equation. And step number 3, we're just solving. So on the right side, 10 plus 9 would be 19. The left side is a perfect square trinomial, and I can factor this into x minus 3 squared. To finish solving, we're going to have to get rid of this exponent. We'll do that by taking the square root, and we'll do that to both sides. So the square root cancels with our exponent. We're left over with x minus 3 equals plus or minus, I'm going to round this to be about 4.36. To finish solving, we're going to add 3 to both sides. Now, since I have a positive 4.36 and a negative 4.36, I'm going to have to actually solve 2 separate equations at this point. So one of them will be x minus 3 is equal to positive 4.36. And since we rounded, we're going to use, instead of using an equal sign, we're going to use the estimation. It's about 4.36. So let's add 3 to both sides. One of my answers will be positive 7.36. The other one will have x minus 3 is about negative 4.36. Add 3 to both sides. X is about negative 1.36. So 2 answers for this one. I'm going to rewrite my answers to be a little bit more clear. X is about 7.36 or negative 1.36. And those will be my answers for example number 1. Let's take a look at example number 2. Same process, this one's just set up a little bit differently. This time we have our x squared term, our bx, but our constant is on the left. So we're going to first have to move that to the right side of the equal sign. That's step number 1. So we're going to subtract 105 from both sides. And now we'll have it set up in the way that we need it for completing the square. What I'm going to do is go ahead and leave a space for our step 2, and we're going to have to add half of the square of our middle term. So let's think about this. Let's see if we can do something in our head. Half of 22, when it's negative, would be negative 11. Negative 11 squared is positive 121. So we're going to be adding 121 to the left side and 121 to the right side. Okay, next step is solve the equation. So to finish solving it, we're going to add these two together, and this turns into 16. The left side factors nicely into x minus 11 squared. Finish solving. Get rid of the squared by square rooting both sides. We have x minus 11 is equal to positive and negative 4. Now it's time to solve two equations, one that uses positive 4, one that uses negative 4. Let's use the positive 4 first. Add 11. So one of our answers is going to be x is equal to 15. Second answer. This time we're using negative 4. And this answer is going to be positive 7. So x will be equal to 15 or 7. Those turned out to be nice numbers. Alright, example number 3. This one's going to be different because you'll see what, even though it's written in the order that we need, x squared plus bx equals c, when we take half of 9, a lot of people will use a decimal, but I like to use a fraction because it's easier to think about squaring a fraction. So since this is set up in step number 1, we're ready to move to step number 2. And let's write this out just to have it as a reference here. Half of 9 can look like 9 over 2. Now if we square this, that's like saying 9 halves times 9 halves, or a shortcut would be to say 9 squared is 81, 2 squared is 4. So when we square our half of our b term, we're going to get 81 over 4. And we're going to add that to both sides. So we have x squared plus 9x plus 81 over 4 is equal to, what I'm going to do is go ahead and make our 136 into a fraction so that it's easier to add this 81 over 4 to. So 136 written with a denominator of 4 is going to mean that my numerator turns into 544. Okay. So I have 544 plus 81, that is 625. On the left side, this is still a perfect square trinomial. Whenever you're completing the square, you'll always have a perfect square trinomial here. So I'm going to have x plus, and the square root of 81 over 4. If we just work backwards from our little work up here at the top, that's going to be 9 halves. And we continue with step 3, solving the equation. So we take the square root of both sides, and I'm going to get x plus 9 halves is equal to, I can take the square root of the top and the square root of the bottom, since both top and bottom are perfect squares. So the square root of the top, 625, that's going to turn into 25, and the square root of 4, that's 2, and since we're taking the square root, it means we've got two possible answers there, plus or minus 25 over 2. Now it's time to solve. Let's use the positive first. Okay, we're going to have to subtract 9 halves from both sides. So that means that x is equal to 16 over 2, which reduces to 8. Second one. Let's use the negative version. Negative 25 over 2. We are still subtracting 9/2 on both sides. And this time we're going to get negative 34 over 2, which reduces to negative 17. So our two answers, lots of work to get there, lots of fractions to deal with, but we end up getting something really nice. 8 or negative 17. That will conclude our video. Have a great day.